All right, we're going to look at the James Roos 2020 trial, question 13d, from a different perspective, I guess, to what they did in their answers. We're just going to look at it purely from a vector point of view and just worrying about the velocities. So in this first part, there's two vectors acting and they get a resultant velocity. All right, so the two vectors that are happening are a vector of 60 metres per minute at some angle, off to the northwest, we imagine, and a vector of 30 metres per minute that's heading straight towards the east. Now, I'm going to set up my vector system, my coordinate system, like north, south, and east and west, but I'm going to set it up so that the east-west is my I direction and north-south is my J direction. And I'm going to look at things just from a 360-degree point of view. So I'm going to be saying that we've got this vector that the swimmer has, and the vector that the swimmer has is going out somewhere in that direction. I'll call that theta, the angle that the swimmer goes at. So maybe it's 120 degrees, right? We'll work out what that is when the time comes. And then we've also got this other vector that's acting, and the other vector that's happening, and I'll do it as a green one, is this way, and that's 30, and that's at 0 degrees, isn't it? Right, the angle that's acting. And we end up with a resultant vector, and they've told us that they want you to go straight across from A to B, from A there to B across the other side. So your resultant vector will be this vector that I'm about to draw in yellow, and it's straight up that way is your resultant vector. Now, as always, all your vectors that are acting add up to give a resultant vector. So I'm just going to add them up to give the resultant vector. So that means, first of all, I've got the swimmer. Now the swimmer is swimming at 60 cos theta in the I direction and 60 sine theta in the J direction, right? That's the swimmer. And then the next vector that we're talking about is we've got the river running, and the river is running at 30 cos 0 in the I direction and 30 sine 0 in the J direction. And finally, our resultant vector is 0 in the I direction, and it's some resultant vector. I'll just call it the resultant vector, sine of 90 in the J direction. Well, it's 90. So to be consistent, I know that we can just see that there's no horizontal part to the resultant, but to be consistent, it's actually R cos 90, and we know cos 90 is 0 in the I direction, and R sine 90 in the J direction. So there's those three vectors. Now the blue and the green one add together to give the resultant vector. All right, so let's do that, but I'll need a bit more room, so I'll go down the bottom of the page here. And the first thing I'm going to do is write down the blue one. It is 60 cos theta I plus 60 sine theta J. And we need to add to that the green one, which is 30 cos 0 I plus 30 sine 0 J. And that's going to be equal to, so just pop an equal sign there, it's going to be equal to, and in yellow I've got R cos 90 I plus R sine 90 J. Okay, now I'm taking a bit more time about this because you knew that where I've got sine 0 in the green, that's equal to nothing. So why write that down? I understand, but for question part 2, there will be values for that. And same with, in the yellow writing, I've got R cos 90. We know cos 90 is 0, and that makes sense to us because the resultant vector is purely going vertically in this situation up to the north. But if I write it out in its fullest form here, that's what I've got. Now, on the left-hand side, I can gather together all the I parts. All right, so on the left-hand side, and how about I just grab a, say, a purple pen now. On the left-hand side, I've got 60 cos theta I parts plus 30 cos 0. Now, look, I know cos 0 is 1, so I'm just going to write 30. I've got that much I parts. And J parts, I've got 60 sine theta J parts, and sine 0 in the green is 0, so 30 sine 0 is 0. So I've got no more J parts. So when I simplify it down, that's my I parts and that's my J parts. And over here, we said before that R cos 90 is 0, right? So I've got 0 I parts, and I've got R sine 90. Sine 90 is 1, so I can work that out here, I guess. And I've got RJ. Well, I don't know what R is, but R is 60 sine theta. However, I'm only trying to work out what theta is in this case, and I can equate together the horizontal, the I components, and the vertical, the J components. So I can say that 60 cos theta plus 30, that on this side, the I parts, is equal to 0. I can also say 60 sine theta is equal to R, but that's not helpful in this circumstance. But 60 cos theta plus 30 equaling 0 is helpful, because that means that cos theta is equal to, and I get minus a half there. So theta turns out to be 120 degrees when you can put that in your calculator. Now, let's go back and realise what we mean by theta. Well, what we mean by theta, if you look at the blue theta up in my top diagram there, it's that complete angle from the east all the way around, like it's a 360 degree angle. So if we're trying to now give a direction, like in compass sort of north, south, east, west terms, 120 degrees is actually only, you go 30 degrees from the north towards the west, don't you? So what I'm trying to say is you've got 90 degrees in here, and then you've got 30 degrees in there. That gives you your 120 degrees all the way around there. But since we're talking north, south, east and west, I can look at that and say that's north and 30 degrees towards the west as my answer. All right, so the question, in which direction should they aim to swim? The answer was north 30 degrees and west. All right, now we can apply that same logic to working out part 2. Now part 2 looks a lot harder. There may be a bit more working out to do because it might not be as simple as equating like just the horizontal parts or just the vertical parts to the final resultant vector. But it could be a very similar question as well. So instead of starting at A and swimming across to B, we're starting at C and swimming across to B. So we're going to still swim at 60 metres per minute, but he's got to start at C. So he's still going to have to swim off to the northwest a little bit, but he doesn't want to end up going straight across the river. He wants to sort of end up going across to the left. So he won't swim with such a great angle. It won't be 30 degrees. Maybe he swim at 10 or 12 or 15 degrees or something like that out towards the northwest. If he didn't, it would drift across quite significantly. If he just tried to swim straight up, the 30 metres would pull him across significantly. So we're going to work it out the same way. We need to work out, if he's doing that, we need to work out what angle he needs to swim at. And so I'm going to draw up a diagram with my vectors in it in the same way as I did before and use the same concepts. So if I can just, get down to a new page, and I'll just insert another page in case I need some more working space and run out of room. So what this question is saying is, if I can just use the same colours as before, we're going to have some swimming vector up this way that on our north, south, east and west, say this is our north, south, east and west, and east, west is our I and north, south is our J. We've got this swimming vector that's going to be around here with some angle, and I'm going to call it theta again, but remembering when I give my final answer that I'll just want the part that's after the 90 degrees. But I'm working out using 360-degree vectors like usual. So, the swimmer's heading off in that direction. So that's one thing that's happening. Another thing that's happening in this, another vector that's happening is this green one across here, like before, which is 30. And finally, we want to have a look at what our resultant vector is. And I'm going to be a bit more specific in a tick, but our resultant vector that I had in yellow last time, it's now got to be sort of swimming up in that direction somewhere. All right, that's our R. Our resultant vector is swimming in that direction. So my blue one and my green one, once again, are going to add together to give me my yellow one. Now, the yellow one is at a certain direction here, and I can work out what that is from the original diagram that they've given me. So I'll just show you that. I'll just draw that up over here. They've got A here, they've got C here, and they've got B, okay, they've got B straight across from it. And something's gone wrong with my, there we go. And if that's the case, and that's 60 metres, and they say the river is 240 metres wide, then that resultant vector that you want to swim straight across there, I mean, you're going to have to swim out to the left because the river's pulling you to the right, but the effect is you'll be swimming straight across along this vector I'm colouring quite dark here. Well, we can figure out what this angle in here is because we've got the 60 and the 240 that we need. And say I just, for a tick, I call that alpha. Tan of alpha is equal to 240 on 60. So alpha equals the inverse tan of 4. And this is in degrees that I'm working. So I'll just pop that in there, the inverse tan of 4. What is well, no, I'll just leave it as the inverse tan of 4. That angle there. It is about, just to get a grip on how big that angle is, shift tan 4, it's about 75 degrees, 57 minutes. It's around, so just to get a grip on it, inverse tan 4 is about 76 degrees. So the resultant vector was about 76 degrees. Now we can do what we did last time. I'm going to write down the 3 vectors that are happening in their component form first of all for you. So the first vector is 60 and then it's cos theta I plus 60 sine theta j. All right, that's what the blue vector is, where theta is some 360-degree measure. The next vector I'm going to write down is what the the river is running at, and the river's running at 30 cos 0I and 30 sine 0j. And finally, I'm going to write down our yellow vector, and our yellow vector, our resultant vector, is r, and then it's inverse tan of 4, so it's cos of this. I'll just write, what is it roughly, 76 degrees? 76 degrees I, and it's r sine of 76 degrees j. So we know the resultant vector, the yellow vector, and we know that the blue one and the green one add up to it. So let's do that. Let's add the blue and the green to get our resultant vector. So what I'm saying is we've got our 60 cos theta I plus 60 sine theta j, and then we add on our green one plus 30 cos 0I plus 30 sine 0j, and we say that that is equal to our yellow one, which is r cos 76I and r sine 76j. Now we can just simplify that down where we know. Well, the only thing that can be disappeared here is the 30 cos theta I. So I'm going to gather all the I parts on the left, and or the j parts on the left. I'll grab a purple pen. I've got 60 cos theta and plus 30 cos 0. 30 cos 0 is 30, so I've got that I plus 60 sine theta, and 30 sine 0 is 0. So that's what I've got for j, and that's equal to r cos 76 degrees I and r sine 76 degrees j. Now this is just straight using 360 degree vectors, and it's quite straightforward in that respect. So what we'll have to do now is see if we can equate together. So we can see that the horizontal, the I parts, are 60 cos theta plus 30 is equal to r cos 76. And we can see that 60 sine theta is equal to r sine 76. So we have two equations and two unknowns. All right, r and theta are the only unknowns, and we've got two equations, so we should be able to solve those out, realising we only want to find theta. We don't really need r, but we've got those two equations. I'll call them equations 1 and 2. Now we know if we divide, we can get rid of that r if we say divide equation 2 by equation 1. And the reason I'm thinking of dividing equation 2 by equation 1 is because sine on cos I find easy. Sine on cos is tan rather than getting cot. So that's what I'm going to do. I'm going to divide equation 2 by equation 1, and I'll write it down the long way. I would get r sine 76 from equation 2 on r cos